a few examples for the integration by parts. So the first question, number 3, here we have integral of x cosine of 5x dx. So how are we going to do it? If I set f as x and then g prime as cosine of 5x dx, then you can see that f prime becomes simply dx, and then g, integral of this one, now becomes sine of 5x over 5. So what I can do is, first I'm going to multiply these two things together. So we have x sine of 5x over 5 minus integral over integral of these two, which becomes sine of 5x over 5 dx. First portion, I can just copy them as it is, x sine of 5x over 5. But when you integrate sine, it's in fact negative cosine. So negative sign was already there, so we get plus cosine of 5x over 25. Then what we end up getting, and then plus c becomes our answer. All right, so that was our first one. Let's look at the second question. How about here? I can assume f as equal to r, and then g prime is equal to e to the r over 2 dr. Then here, f prime becomes dr, and g becomes integration of this one. We get 2 e to the r over 2. So now, then this one should be equal to, then I'm going to multiply these two things together first, 2r e to the r over 2, and minus integral of 2 e to the r over 2 dr. So first component I'm going to write down as it is, 2r e to the r over 2, and then second one, when I integrate this one, another 2 has to be multiplied, so we get minus 4 e to the r over 2 plus c becomes the answer. Not bad. Let's look at number 7. How about in this case, what's going to be happening? Similarly, I'm going to first start off with f equals x squared, and then g prime equals sine of pi x dx. Then what is f prime equal to? That's 2x dx. And then g becomes, yes, negative cosine of pi x over pi. Now then, this one should be equal to, I'm going to multiply f and g first, so we get negative x squared cosine of pi x over pi minus these two. But another negative sign, make that into positive. And we get integral. I can factor out 2 and pi. So 2 over pi x cosine of pi x dx. While the integral has been simplified, but it's not done, I still have to do x cosine of pi x. And this is similar to one of the questions that we have done earlier. So right now, what I'm going to do is, why don't I just focus on this one a little bit. So that expression now, if I have to just focus on that portion alone, x cosine of pi x dx. Similarly, I'm going to do f has to be equal to x, and g prime will be equal to cosine of pi x dx. And what is f prime? That's dx. What is g? That's right, there will be sine of pi x over pi. So what we get to realize is integral of this expression now becomes x sine of pi x over pi minus integral of sine of pi x over pi dx. But you can see that this one should be equal to, I'm going to write down the first one as it is, x sine of pi x over pi, and then negative sign is the derivative of the cosine, so we can say plus cosine of pi x over, it has to be pi squared by the chain rule, and then plus c. Then this expression that I have has to be substituted in for this place. So then what do we end up getting, guys? It'll be, let me reduce this right up a little bit. Because I think I'm going to need some space here, is equal to negative x squared cosine of pi x over pi plus 2 over pi, and then I have to write this one down. So we get x sine of pi x over pi plus cosine of pi x over pi squared plus c. Alrighty. That was pretty long, but that's basically what we could have done. So as you can see, sometimes we might end up doing by parts twice. All right, let's move on to number 9. How about this one? How would you be able to do this? I can set f as ln of 2x plus 1, but I don't know what g prime is equal to. Maybe I just have it as a 1 dx, or dx itself. How about that? Then in that case, what is f prime equal to? It'll be 1 over 2x plus 1 multiplied by 2, so I'm going to write down 2 on top and dx. And g now becomes x. So when you integrate this one, what we end up getting is, we're going to write down x ln of 2x plus 1 minus these two put together, so we get 2x over 2x plus 1 dx. Now, how would you be able to integrate the second portion? You know what? I can, because 2x divided by 2x plus 1, what if I were to add 1? Then I know that top and bottom is equal to each other, so it would have been 1. But I cannot just add 1, so I have to subtract 1. So what this one ends up being is, if I have to just work on this portion, don't forget I have negative sign in here. This should have been the same thing as 2x plus 1 over 2x plus 1. And then minus 1 over 2x plus 1 dx. Then you can see that my first component here, first term becomes 1, so we get 1 minus 1 over 2x plus 1 dx. So when you integrate the first component here, it becomes x. Second one is minus ln of 2x plus 1. I didn't put down the absolute value because I didn't have absolute value initially, 2x plus 1. So I'm assuming that it is okay here. And by the chain rule, I'm going to divide this one by 2. And plus c. So I have to put this one in place of red expression over here. Then my final answer now becomes x ln of 2x plus 1. And then minus, because of this negative sign, it's going to switch the signs here, negative x plus ln of 2x plus 1 over 2 plus c. Plus it doesn't really matter one way or the other. So with that one, we are done for homework, I think. Yep, and I'll see you later.